Hello everyone, welcome back to my YouTube channel, your ultimate destination for tech and data science knowledge. Today we are tackling some important data science exam questions step by step. So grab your notes because by the end of this video, you'll master these concepts like a pro. Let's dive in. So our first question is all about transforming structured data into format suitable for machine learning. Think of unstructured data as a messy raw material like text, images, or audio files. For example, uh, a complaint text like this: the noise in my area is unbearable at night. We need to convert this into a machine readable format. Here's how. Transforming it into several steps, such as text cleaning. For example, the noise in my area is unbearable at night becomes noise unbearable at night. Then we perform tokenization, split the text into individual individual words or tokens, normalize, convert the words to lowercase, stemming, and lemmatization. For instance, running becomes run. Feature extraction. We use techniques like bag of words, TF-IDF, or word embeddings like word to VEC to represent the text numerically. Now, why is legal classification important? It helps to map complaints to correct legal provisions for faster redressals. Methods like TF-IDF calculate term weights, while word to VEC captures word meanings and relationships. Here is the explanation of TF-IDF and word to VEC conversion. Now we will move on to next question, that is our second question, life cycle of data science. Think of this as a roadmap for any project. Here's a quick problem. Here is a quick breakdown. We will define the problem by understanding the objective should be understanding the business needs. The key details in the tasks are identifying objectives, constraints, and success metrics. Tools and libraries are not required. Domain expertise as well as Python request beautiful soup, SQL, etc. Then we will perform data collection. Gather relevant data from sources must be our objective, and the key tasks should be collect structured data and unstructured data, such as from APIs or web by web scraping. Tools libraries are Python and SQL. Then we'll data exploration and pre-processing. The objective is clean and prepared data. Handle missing values, outliers, normalization, feature selection, etc. Libraries or tools are pandas, numpy, sklearn, scikit-learn, or feature engineering. In this, our objective is enhanced data quality for models. Then the key objective should be key tasks are create new features, transform existing ones. Scikit-learn feature tools are the libraries for this feature engineering. Then we will perform model selection and building. Train models on prepared data should be our objective, and the key tasks would be use algorithms. And like examples of these algorithms are regression, classification, etc. And the key tools such as scikit-learn, TensorFlow, PyTorch, scikit-learn, etc. libraries would should be used in the model selection process. Then we will evaluate model by objectivizing, assess model performance. Use metrics like accuracy, precision, recall, F1 square, F1 score, etc. by using metrics module, Flask, etc. Then we will deploy our model for real world use by using the setup of APIs or embed in applications. We will use Flask libraries, Fast API, Docker, etc. tools. Then we will monitor and maintain our system. We will ensure that the model's reliability post deployment, and key tasks would be tracking accuracy, handling data drift, etc. The tools would be Grafana and Prometheus. Then communication and reporting would be done by sharing the findings with stakeholders. The key tasks would be create visualization, report or dashboards, and the uh, key tools or libraries would be Tableau, Power BI, Matplot library. Now moving on to our next question, that is question number 3: role of text mining in grievance redressal systems. Let's talk about how text mining powers grievance redressal systems. Imagine an automated system uh, uh, that reads citizen complaints and matches them to relevant legal problems. Uh, Here's how it works: remove noise, get rid of stop words, punctuation, etc. Normalize text, uh, lowercase everything, and stem or lematize words. Then we will need to tokenize, split text into words or grams, vectorize represents text numerically using TF-IDF or word embeddings, feature selection, TF feature selection, identify the significant terms for matching complaints to IPC sections. This saves times, improves accuracy of handling accuracy, and ensures fair handling of the complaints. Then our question number 4 is linear regression. Now let's simplify linear regression. Imagine you are predicting sales based on advertisement spend. Linear regression models this as y equal to mx plus c, where x where y is dependent variable sales and x is independent variable ad spend. M is the slope and C is intercept. The goal is to find the line of best fit, minimize the error between predicted and actual values. Here's how. Initialize parameters, start with random values of M and C. Calculate error. Use mean squared error as the cost function. Update parameters. Apply gradient descent to optimize M and C. Simple, right? Now let's move on to our next question. Clustering with k-means. Time to cluster some data. Let's split this data set: 2, 4, 10, 12, 2, 20, 30, 11, 25 into two clusters using k-means. Pick uh, random centroids. Set say C1 equal to 4 and C2 equal to 25. Assign each point to closest centroid cluster. uh, Cluster 1 equal to 2, 4, 10, 12, 2, 11. Cluster 2 equal to 20, 35, 20, 30, 25. Update the centroids to the mean of each cluster. New C1 mean of cluster 1. New C2 should be mean of cluster 2. Visualize the convergence of centroids step by step. Repeat this until centroids stabilize. Easy, right? Let's move on to next question. Question number 6: k-mean versus hierarchical clustering. So the clustering process is partitioned into k clusters. while in hierarchical clustering creates a tree like dendrogram. The scalability of clustering in K-means is it handles large datasets efficiently, and in hierarchical clustering is suitable for smaller datasets. Clustering visualization K-means cannot visualize uh, relationships, while hierarchical clustering provides a dendrogram for visualization. Cluster shapes works well with spherical clusters in k-means, while can it can capture arbitrary cluster shapes in hierarchical clustering. So let's move on to next question. Question number 7. Classifying mm, loans using entropy or Gini index. Finally, let's classify loans into risk classes using entropy or Gini index. H of x equal to minus summation p of x log 2, and the Gini index 2px. Gini index measures impurity as Gini equal to 1 minus summation p of x square. We calculate this for each feature and split the database based on highest information, gain entropy, or lower Gini index. The process repeats until we classify all data. Now, moving on to question number 8, impact of data processing techniques. First, let's talk about how data pre-processing techniques like stop word removal and impact stemming impact model performance. Data pre-processing is like preparing ingredients before cooking it. It ensures your model runs smoothly and efficiently. Here's the breakdown. The impact of stop word removal show a visual of words like the, is, in, of being removed from the text. Stop words are common words that don't add significant meaning to your analysis. For example, removing stop words transform the sentence. The quick brown fox jumps over the lazy dog into quick brown fox jumps lazy dog. Why is this important? Improves computational efficiency by focusing on meaningful words. Slide display precision improves because irrelevant words are excluded. Recall may slightly decrease in rare cases if stop words carry subtle context. F1 score improves overall due to better uh, balance between precision and recall. Now let's explore stemming. Impact of stemming. Stemming reduces words to their root form, which helps to model the treat variations of word as the same. Why does it matter? It improves text matching by aligning word variations, reduce feature sparsity, meaning fewer ununique tokens and more robust trainings. The precision improves by generalizing similar terms. Recall increases because all variations are accounted for. F1 score improves as model better generalized features. Pre-processing is the foundation of better model performance. Clean data equals accurate models, etc. Now let's move on to our last question, that is question number 9, assessing performance metrics. Now let's evaluate the system using precision recall and F1 score. Precision tells us how many of our model's positives are uh, positive predictions were actually correct. It's about accuracy. Uh, Recall measures how many actual positives were successfully predicted. It's about sensitivity. F1 score balances precision and recall, making uh, performance make recall, making it a deal for evaluating performances when data is imbalanced. Now let's move on to our last question: grievance redressal system (TF-IDF) and TF-IDF. Now let's calculate TF D4 T6, IDF T6, and TF IDF D4 T6 step by step using uh, the given table. This table will be used. So uh, term frequency measures how often terms appear in document normalized by the total terms in the document. The formula is TF D comma T is equal to frequency terms T in document D, total terms in D, TF comma D, DF D comma T is equal to total terms in D, frequency of term T in document D. Frequency of D4 is equal to 15, and total terms in D4 equal to 0 plus 12 plus 0 plus 0 plus 5 plus 15 plus 17 equals to 49. So TF D4 comma TF D4 comma T6 equal to 49 15, which is equal to 0.3061. Now IDF measures the importance of term across all documents. This formula is IDF T is equal to log total documents by documents containing T plus 1. Total documents equal to 4. Document containing T6 D6 equal to D1 D3 D4. 3 documents. So TF IDF T6 is equal to 3 by 4 plus 1 log 3 4 plus 1, which is approximately equal to 1.176. TF IDF combines TF and IDF to measure a term's importance in a specific document. So in this case, the TF IDF D4 comma T6 equal to 0.3599. Here is our solution. That's how we calculate TF-IDF. It helps us understand uh, which terms are most important in a document. Now, what is document similarity? To determine if two complaint documents are similar, we use cosine similarity. Cosine similarity formula is given here. Now, let's create term frequency vectors for documents. Normalize the vectors, compute the dot product and divide by magnitudes. Document with higher cosine similarity score are more alike. This is incredibly useful for grouping complaints in automated systems. And that's it. We explored the magic of data preprocessing, TF-IDF, and document similarity in grievance redressal systems. If you learned something new, give this video a thumbs up and subscribe for more exciting content. Have questions? Drop them in the comment box, and don't forget to like, subscribe, and share. Thank you for watching. Have a nice day.